In this video, we're going to go over what a linked list is, and by the end of it, you'll be a master of the link. List. A linked list is just a type of list that doesn't use something like an array or a native data structure to store data. So in Python, we don't use a list of 1, 2, 3, for example. Quickly though, why can these type of lists be bad to use? Well, for most of the time you're going to use a list, they're not actually bad to use if it's just a small list. But when the list gets big, they're not actually very memory efficient. The reason for this is, say you have a list of 100,000 elements, like a big list. Well, say you remove the first element of that list. Now everything, so, the first element is a 0. So everything like the one element or the first element, and then second and third, all the way to 99,999th element, they now all have to shift 1 over, meaning the memory locations for everything has to shift 1 over, and the pointer for everything has to shift 1 over, which, as the list grows, is actually pretty expensive. So instead, we can make a linked list. Linked list. This is probably like a hate symbol or something, isn't it? I apologize if that's the case. I don't know. A linked list is basically a list where you have the first element and it knows about the second element. Then the second element knows about the third element. And the third element knows about the fourth element, and so on and so on. So if you need to remove an element from the linked list, you just need to shuffle a couple pointers around. So now 2 is no longer pointing to 3, it's just pointing to 4. And there you go. Number 3 is gone. Easy as that. Additionally, when you want to insert an element, it's also super easy because you just get, say, number 2, and you see what number 2 is pointing at. Then you make your new element, you point that to whatever number 2 is pointing at, and have number 2 point to this new element. And there you go. You've shoved some new element right up in there. Just maybe not the best way to say it, but also kind of correct. All right, let's jump into Python and actually make a linked list. To start out, we're going to paste in this class here, which is our base for our linked list. And it just has a basic init function. And we just create a head, a tail, and length as variables associated with our class itself. And we just set the head to none, the tail to none, and the length to 0. We then need to create another class that we'll use for the items we're storing in our list. So let me add a class here. Now this class we're just going to call item. It's going to have an init function, and we're just going to pass a value to it. And then this item will have a child, when we're just going to set it to none to start. Now, let's make it so that we can add some stuff to our list by creating a push function. So this push function here basically allows you to pass in a value, it will create a new item, and then it will set up the pointers appropriately. So if head doesn't exist, so if this is the first item, then we're going to set the head to this new item. We're going to set the child of head to this new item. It's going to point to itself, and then set the end to this new item as well, and then increase our length. If it's not a new item, we're going to set the tail's child to this new item that we've added, and then set the tail itself to this node. Okay, so let's try out our list that we have so far. I'm going to paste in some testing code here. Great. So let's go ahead and run this. Perfect. So beautiful. I mean, it probably worked, right? We didn't get an error, but this is not exactly the most useful thing ever. Let's create a string function to make it so that we can actually print stuff out and make it less ugly. Great. So this string function we've just created here, it's just going to return empty if there's no head. And then it's going to basically just loop over each element and print things out, or add things to our string, and then we're going to return this element. So we're just going to get the element and then have a pointer, because that's kind of how linked lists works, right? They just point to things. And then we're going to get the next one, and we're going to keep going until we hit the end. And then this is the final thing we'll print, which is just the end of the linked list. So let's run this again. Great. Now we can actually see that it did work rather than just getting a memory location. So we get 1, 2, 3, 4, end, and then end of line linked list. I want to say end of line, end of linked list. Now let's make it so we can remove elements from the start of our list. So we're going to paste in another function for our class, and this will be the shift function. So what this will do is we'll remove something from the start. So if, and it's going to be returning this, just to be clear. So if there is nothing, because the head is always the start, then we return nothing. Otherwise, we're going to set the node to the current head, then we're going to set the head to the node's child, and then we're going to decrement the count or the length. So we're going to basically take one away from it. And then if the length is equal to 0, then set the tail to be none. And then we're going to return our node. So this means we can now remove elements from our linked list in constant time, which is a big O notation, which we'll go over eventually. But this is huge. It means that we can basically remove elements instantly. So let's do a little extra pasting here. Go ahead and run this. And we can see we're printing out our linked list. Then we're removing elements one at a time. And then we're printing off the length, which is 0, and done, which is just here. But constant time is a huge, huge deal here because it means that it basically runs instantly. We don't have to loop over anything, or we just can point to the next thing and say, get that. It's very, very fast. What if we want to add an element to the middle of our linked list? Well, let's add a function that will be able to support something like that. So I'm adding this after our push because it's something that's going to add things. So this one's a little bit more complicated. So basically we're saying that we're going to add a value after a given value. So we create our new item that we're going to add. We start our pointer at head while the pointer is not equal to none. So we're not at the end of the list, and the pointer's value does not equal the target. Then the pointer equals pointer.child. Basically, we just keep moving along the list. And then if the pointer does not equal none, basically we reached a point where the value, the target has been found, then we're going to set the node's child to the pointer's child and the pointer's child to the node. And then otherwise, then we're going to set the child of the tail's node to this one and set the tail to be this. Basically, we're just going to add it to the end. Then finally, we're going to remember to increase the length here. So let's give this a try. So we're printing out our linked list. Let's do linked list insert an 8 after number 6. So in this case, we don't have a number 6, so we should see 1, 2, 3, 4, and 8. And we're going to print that list again. Or sorry, 1, 2, 3, 4, 6. 1, 2, 3, 4, and 6. And then let's do after, we want to add it after the 3. And now we can see we get 1, 2, 3, 6, 4, end. Now, you again might think that this is actually really slow, but the reason this is fast is because we basically just have to loop through our list at most once. And every element in the list is just, we already know as soon as we get one element, we know which one the next one is. So we can do that basically instantly. Or the slowest that this could actually take is order n, which again, when we get into big O notation, will make a little bit more sense. But this is a big deal because again, an insert means we don't have to shift anything else around because we're just correcting the pointers. That's it. Now you know how a linked list works. Pretty easy, right? You've now added another tool to your ever-growing tool belt. It's going to be pretty frickin' heavy soon. Remember, I'm Jake, you're awesome, and this has been Linked Lists in Python. Cheers.